Across India's 75 million MSMEs, you will find the powerful engine responsible for over a third of national manufacturing value added. In FY24, the MSME sector captured a 35.4% share of manufacturing value, roughly $0.174 trillion. To match 2047 targets, it must hit a 50% share, pushing total value to $3.38 trillion. This 19 times multiplier represents a $3.2 trillion growth opportunity. Right now, most of these informal enterprises are caught in a low productivity trap. Thin margins, high rework rates, and operational friction strictly cap their maximum daily output, preventing them from taking on larger, more complex orders. Reaching that multi-trillion-dollar target requires structural intervention. Linear capacity increases, simply adding more manual labor to an inefficient system, will fall short. Micro-enterprises must reimagine how they generate and capture value. This image illustrates an informal manufacturing floor today. The dense workforce relies entirely on manual operators, with individual stations lacking integrated digital feedback systems. Treating AI as an isolated technology purchase fails in these environments. Buying a single piece of software without upgrading the underlying workflow drains capital without delivering scalable returns. In these manual environments, data is generated at every station, but is immediately lost because there is no mechanism to record it. Edge AI provides the local processing power to capture that data at the source, transforming a static workbench into a learning system that improves accuracy with every hour of usage. The objective of this integration is repositioning the firm's economic standing. A factory producing standard commodities at tight margins is vulnerable to slight shifts in labor costs. AI allows these businesses to transition away from being localized, cost-based suppliers. The true value of this intelligence lies in accessing global value chains. International manufacturing networks require suppliers who can guarantee absolute consistency, metrics that AI-enabled quality control provides, allowing MSMEs to operate as competitive nodes internationally. Currently, severe capability barriers block this integration. Foreign buyers demand stringent precision manufacturing, rapid iteration in generative design, and flawless compliance tracking, which manual operations struggle to maintain. Capturing this trillion-dollar edge means MSMEs must stop treating algorithms as expenses. They must architect learning engines directly into their operations. Before introducing any algorithms, a business must define exactly how AI will interact with its physical operations. This organized, highly structured factory floor illustrates an ideal baseline, ready to map data directly to specific production goals. We can organize this integration into 3 specific operational tiers. This diagram outlines the AI value taxonomy, starting at the foundational base layer, the scaler. At this level, AI attacks processing times and resource limits. By automating repetitive visual inspections or manual data entry, the system directly reduces operating frictions, increasing the baseline throughput of the factory. Once throughput is stabilized, the system scales up to the middle tier, the enricher. Here, the objective shifts from raw speed to augmenting human decision-making and creativity. A prime example of an enricher capability is predictive maintenance. By analyzing subtle acoustic or vibrational anomalies that traditional sensors miss, AI alerts supervisors to impending equipment failures before an expensive, unplanned shutdown occurs. The apex of this taxonomy is the reinventor tier. At this level, AI stops optimizing existing operations and disrupts how the business captures value. Instead of simply manufacturing and selling a physical compressor, an enterprise uses continuous data feeds to pivot to a product-as-a-service model. They lease the machine and charge the customer strictly for the compressed air generated, backed by AI-driven maintenance guarantees. This taxonomy proves that AI is not a monolith. Its true utility is dictated entirely by how deeply the algorithms penetrate the core operating logic of the business. To move a resource-strapped factory up that pyramid, businesses need a systemic adoption mechanism. This is the 3A2I framework, a nonlinear operational structure designed for scale. The left hemisphere represents the foundation: access, acceptance, and assimilation. For survival-focused MSMEs, frugal diffusion is critical here. Expensive overhauls are ignored in favor of highly targeted, low-cost experiments. The right hemisphere outlines the pathways to success: implementation and institutionalization. This phase translates raw pilot data into scalable, enduring systems that govern daily output. We can map this framework directly to a physical engineering scenario on the shop floor. Consider a single specific piece of machinery plagued by surface defects and labeling errors. In the access phase, the MSME bypasses heavy capital expenditure. Operators simply mount existing smartphones to the production line, utilizing frugal computer vision applications to define a rule-based checklist for acceptable parts. During the acceptance phase, management proves the tool's value to the workforce. By demonstrating that early AI inspection drastically reduces end-of-line scrap, rework hours, and client penalties, they secure necessary employee buy-in. The assimilation leap requires scaling the hardware. The factory moves away from isolated smartphones, plugging into shared infrastructure via local common facility centers to access industrial-grade sensors and shared GPU computing power. Finally, the operation reaches the institutionalization phase. The AI-driven defect checks are permanently embedded into formal standard operating procedures, and algorithm-generated reports become mandatory metrics in daily production meetings. This structured architecture prevents pilot purgatory. It ensures a $50 smartphone experiment physically evolves into a continuously learning, factory-wide quality system. Sustaining this intelligence always requires human capital. However, a standard heavy manufacturing MSME cannot realistically recruit, pay, and retain a dedicated, highly specialized team of AI data scientists in-house. The solution exists in a latent economic resource. Approximately 20% of Indian MSMEs are led by women, yet 95% of those businesses remain micro, informal, and excluded from advanced supply networks. We can restructure the industrial ecosystem by intentionally anchoring specialized data and analytic services within these women-led MSME nodes. These specialized service nodes process the raw factory output and return high-value intelligence. They provide the core manufacturing hubs with predictive maintenance analytics, precise ESG tracking, and supply chain optimization. This network is validated and funded through localized incubators, industry associations, and preferential procurement mandates established by large anchor corporates. By operating on this new hub-and-spoke model, the ecosystem eliminates the need for every single factory to build and maintain its own localized AI infrastructure from scratch. Integrating women into this high-value intelligence layer addresses massive gender disparities in technical fields, while re-architecting the industrial fabric required for national scale. A fully institutionalized MSME operates with provable, data-backed consistency. It delivers the flawless precision manufacturing and automated compliance required by international buyers. This technological capability dismantles the traditional barriers of trust and variable quality that historically kept Indian micro-enterprises isolated from foreign markets. The firm integrates into global value chains, pushing its products through AI-enabled e-commerce export hubs and leveraging digital public infrastructure to interface directly with international partners. As production scales, algorithmic credit scoring evaluates the firm based on continuous, verified digital transaction data rather than static collateral, injecting the capital needed to fulfill massive global orders. As this AI strategy proliferates, macroeconomic indicators will climb aggressively. AI is estimated to contribute 19.2% of India's manufacturing growth by 2035. This velocity drives the sector toward achieving the 50% GVA share target, cementing a multi-trillion-dollar industrial economy. The $3.2 trillion shift depends on architecting a cognitive industrial network, one that pairs India's massive labor pool with the micro-level precision required to match global scale.